Number 24 is our good old 3 by 3 that we need to find. So how do we do this one? If you recall, our goal to do this is by elimination. So we want to choose a variable to eliminate, whichever one looks easiest. And I can, just by looking at it, I think most of us would agree that the x's look like it's probably the easiest. So I'm going to just box that so we know that's what we're looking at. So how do we eliminate our x's? We have to eliminate it twice. Remember, we want two equations, both of them without an x-intercept, or without the x's. So I'm going to choose, let's just say maybe the first two. And I can see there's a 3x here, so to cancel it, I'm going to need the opposite on here. So I'm going to multiply that first equation by minus 3. And rewriting this is going to give me minus 3x. Negative 3 times 2 is minus 6y. Negative 3 times 3 is minus 9z. Is equal to negative 3 times negative times 1 is minus 3. Now copying the other one directly underneath it, I get 3x plus 3y plus 4z is equal to 7. And now we can add straight down to get our first equation. As we wanted, these x's cancel. And I'm left with minus 3y minus 5z is equal to 4. And I'm going to label this equation 1 so we can find it later. Next, I'm going to choose two different ones. I need to use the bottom one because I ignored it. And the easiest one it looks like to cancel with that 2x is going to be the top one again. So I use the top and the bottom. And in order to cancel out with a 2x, I'm going to multiply that first one by minus 2. So I'll have an opposite of 2x and negative 2x. So multiplying that across, I get minus 2x minus 4y minus 6z is equal to minus 2. I'll recopy the other one, which is 2x 4y plus 4y plus 7z is equal to 3. And this is very nice because not only do our x's cancel, but our y's cancel too. So this makes it one step less that we have to do. And here when I add straight down, I get 1z is equal to 1. And that's our equation 2. Now normally what we need to do is do the elimination process again to eliminate another variable and get one variable by itself. But here we already eliminated the y's. So now we can just go back to our last step, which is just back substitution. Right? I have the value of z, and I have an equation where I can plug in my value of z. So let's do that. I'm going to put negative 3y minus 5 times z, which we now know is 1. And solving this out gives me minus 3y minus 5 is equal to 4. And now we can get y by itself. So plus 5, negative 3y is equal to 9. And if I divide by negative 3, I get y is equal to negative 3. And I can see my answer is already A. But just in case you need to do this on the actual test, let's look at how we would find x. Because so far we have z, we have y. To find x, we just choose one of these equations, like the first one, this looks nice. And we can substitute our value of y and z to solve for x. So to do that, let's go to do that. We have x plus 2 times y, which we now see our y is minus 3. Plus 3 times z, which we also know our z value is 1, is equal to 1. And now we just solve for x. So let's simplify this a little. Minus 6 plus 3 is equal to 1. That's minus 3. And if I add 3 to both sides, I get 4. And so none of these other ones are there except for y equals 3, so that's our answer.